I already introduced myself. Also here tonight, our primary presenter, Joe Bischoff, back in the red vest. He's a senior aquatic ecologist with FAR Engineering. We also have with us Scott Sobiek. He's also with FAR and serves as our Watershed District Engineer. And then also we have with us Dylan Monahan. He is a watershed planner with the Watershed District. So just to give you an idea of what we're going to talk about tonight, we're just going to go over an introduction to what we mean when we say a systems approach to watershed and lake management. We're going to talk about what we mean when we say a healthy lake and watershed. What does that mean for watersheds and lakes in our built environment that we have here out here in the suburbs, and also talk about the current conditions of the lakes that we are talking or focused on tonight, which is Anne, Lucy, and Susan. And then finally, we'll talk about next steps. What happens when we get these lake management plans developed. So just to start with the basics, what is a watershed? It really is just an area of land that drains toward a water body such as a lake, a pond, a river, a creek. That's what it is. And you can look at a watershed from a very large scale, say like the Minnesota River, very large area of land that drains to the Minnesota River. Or you can look at watersheds on a smaller scale, which is what we're doing with this study. So a smaller scale means that the area of land that drains into, for example, up here, Lake Lucy. So everything within this gold boundary is the land that drains into Lake Lucy. So that's the level that we're talking about tonight. One of the big things we consider when we're studying our watersheds is impervious surfaces. So here within the Riley Purgatory Bluff Creek Watershed District, we have about a 24% average of impervious surface. Now, anything that's over 10% in a watershed means the water body is going to be negatively impacted. So what we're dealing with here is a lot of built environment impacting our watersheds. And then, not surprising, when we look at these watersheds, again, why we're doing the systems approach is we're considering that type of information. So what do we mean when we talk about a systems approach for lake and watershed management? You could also say a holistic approach to lake and watersheds management. So a systems approach really considers the lake characteristics, the lake's watershed characteristics, balancing those various goals that we want to consider within our watershed, also the various layered systems. And so these are both the environmental systems, such as an ecosystem, as well as those built environments, such as roadway systems, housing, stormwater conveyance, those types of things. So where does this fit into us as a watershed district as a whole? So we are guided by our 10-year watershed management plan. And we are in the process right now of starting to update that 10-year watershed management plan. You can see the next one will be actively in place by 2028. So part of what we're doing with this systems approach to a watershed and lake management plan development is that'll help inform development of our 10-year management plan. So with this process, we are going to be identifying potential projects. We're going to be talking about what are those goals we want to include in our next 10-year plan. And along with that, we also have our ecosystem health action plan. A draft was finalized I think about a year and a half ago. And so that study was looking at the ecosystem health and what are the 70 plus strategies that we could implement to address ecosystem health. So again, that will also feed into our update of our 10-year management plan. So that's sort of the big picture. And what we're focusing on right now with what we're talking about tonight, the systems approach plan development, is we're focusing on 5 lakes. And tonight we're going to specifically talk about Anne, Lucy, and Susan. These lakes were chosen for various reasons. One, that they're representative of our watershed lakes as a whole, I should say watershed district lakes as a whole. And hopefully we can take a lot of the information that we're learning through this process for these lakes and translate that to our other lakes. So what do you think makes for a healthy lake and watershed? Does anyone have any have any thoughts? What does it mean to you when you say healthy lake or healthy watershed? Just throw it out.
Preventing chemicals and waste from housing and buildings to go into the lake without it being filtered or cleaned first.
Right. So reducing the pollutants that are entering our water bodies. Anyone else? You had adjectives, what you see as what a healthy lake is? Is it dark and dirty? Is it
Clear water, you know, if you can see the bottom at 7 or 8 feet, that's one indication that it's healthy.
right? Good water clarity. What about anyone else? Their adjective?
Lack of blue-green algae or the algae blooms.
Right. Low levels of blue-green algae, also known as cyanobacteria, which can release those toxins that, if they build up enough, can be irritating or even sicken people and pets.
Minimizing motorized boats and other aquatic toys. I mean, I would think that would make a lake cleaner, like Lake Ann. Doesn't allow any motorized or gas powered or.
So disturbance from watercraft, or even perhaps not even just disturbance of lake sediments, but perhaps noise and disturbing wildlife, that type of thing. Anyone else?
About vegetation.
Aquatic vegetation? Yes or no on it?
Depends. A balanced ecosystem where you have birds and you have fish.
There you go.
can swim in it and you can play on it. I want it all.
Right, a healthy lake, aquatic vegetation plays an important role. As you all see the handout in front of you, we talked about that tonight. With that, I'm going to turn it over to Joe Bischoff. He is the star of the show tonight, and he's going to talk you through what we're doing and what the next steps are.
Is Lake Minnewaska not in this?
No, that's not within our watershed district. Very close.
Clicker work.
I have not tried the clicker. I'm a down arrow.
All right, I'll do it the other way. Okay, so are you guys ready? We're going to take a whole semester of lake ecology and do it in about 15 minutes.
Good.
Right? So I think, this is why we wanted to start the discussion on what you think is a healthy lake. I'm going to tell you what I think is a healthy lake and what are the key components of that and what's a healthy watershed and why we're doing this study, how we're going to try to bring this all together to try to connect the watershed and the lake and come up with a healthier ecosystem. So it's a lake and watershed plan where we're trying to look at these different functions, these ecosystem functions, and how they connect to each other and how we can manage them that way. Okay, so it's a systems approach. That's why we talk about systems. It's ecosystems, but it's connecting all these systems together to come up with a better plan. So let's just start with a little context. This is Lake Lucy and Lake Ann. The way that I'm gonna work at these two go together, right? They go hand in hand. They very much function together. What happens in Lucy has a strong effect on Lake Ann, but by the time Lake Ann discharges all the way down to Lake Susan, they disconnect again. So Lake Susan's driven more by its own watershed and less by what's coming out of Lake Ann. Part of that's because Lake Ann has good water quality, and what it's sending down to the next lake is protecting that water quality. So what we see in Lake Susan is really driven by the watershed and what's going on in the lake itself. Okay, so when I go through this, I'm going to talk about Lucy and Ann together, and then I'm going to talk about Susan as the next one downstream, but they all do flow into each other. So these are pretty typical, what we would call suburban lakes. They have developed watersheds where you see a lot of development, neighborhoods and other stuff, and then sometimes you have some commercial areas where this is a higher density development. All of these are connected through drainage systems, usually stormwater pipes, curb and gutter, so everything, all the rain that falls on the rooftops, the parking lots goes into a pipe, and that goes directly to the lake or goes through a series of wetlands and ponds before it gets down to the lake. These are fairly small systems at 88 and 119 acres. Those are not super large lakes, which actually makes my life a little bit easier. Smaller lakes are easier to manage than the big, large ones that get really complex. So that's actually a good thing. you're going to hear me talk about terms like littoral area. So the maximum depth, both of these, Ann Lake is a deep lake, and then Lucy is a shallow lake. And I'm going to talk about why those are different. But both of them have fairly large littoral areas. The littoral area is where you expect light to penetrate all the way to the sediments, and you'll get plant growth. Okay. So what I say is, so for Lake Ann, 45 acres of the 119 acres would be expected to support plant growth. And that number goes up and down. If you have very clear water, you can see plants out to 18, 20, 20 plus feet. If you have more turbid water, that plant growth tends to be shallower, so you don't get the light penetration all the way down there. Okay. But this is important about how a lake functions, is how much littoral area or how much of it's shallow does affect how that lake operates from an ecosystem and from a water quality basis. Okay, they both have relatively small watersheds. As you see, Lake Ann has a direct watershed of only 257 acres. That's fairly undeveloped. That's kind of this direct area here. And then the rest of whatever goes through Lucy comes down to Lake Ann too. And Lucy has about a direct watershed of about 988 acres. So you add the 988 plus 257, you get the total drainage that's in there. Okay, but when we look at this, we're going to look at when we look at Lake Ann, we look at what's coming out of Lake Lucy, and for Lake Lucy, we look directly into that watershed as to what's impacting the lake there. Okay, and then our disconnected lake is Lake Susan. So you see Lake Ann discharges here, goes through the creek. This is Riley Creek, right? Riley Creek? Purgatory. I get them mixed up, but Riley Creek comes down through, and then it drains into Lake Susan, and this eventually goes down into Rice Marsh Lake. And from Rice Marsh Lake, it goes into Lake Riley, and then out to the Mississippi River. Minnesota, sorry. Minnesota, got it.
Then to the Mississippi River.
Yeah, I did say it. Yep, I did say it. Yep, I got it. So anyway, so it changed. So the reason that we're doing some of these lakes too is there's been a lot of work done on Rice Marsh Lake and Lake Riley, and we've had a lot of success in improving water quality. And now we're moving upstream because we want to protect that water quality by protecting the lakes upstream of the chain. Okay.
Where is that? The creek that comes out of Lake Ann? I don't know where. I've been in Lake Ann in the trees. I don't see any creek in there.
Coming out of Lake Ann, it might be a pipe. I don't know.
So coming out of Lake Ann, it's a natural channel. It's hard to see. It's back in some cattails. So if you're on the water, you're going to have a hard time seeing it. And it runs through private property.
But it drains down through there. Then you have all this direct watershed that comes into Lake Susan. There's some pretty developed areas, kind of commercial or industrial areas that have a lot of impervious surface, and these all make their way down into Lake Susan. There's a big pond, Lake Susan Park Pond, is that what we call it, right? The big pond that drains down into Lake Susan here. So that has a lot of influence on what's going on. Again, this lake is very littoral, meaning that 83 of the 88 acres would be expected to get plant growth. So this is a shallow lake system. We would expect in a healthy condition that you would have plants growing pretty much throughout the whole lake itself. Okay, so you don't have those plants now as much because of the turbidity and amount of algal growth and things that are going on in that system. It has a fairly large watershed because it's picking up everything that's going on in Lake Ann and Lake Lucy, and it has a pretty large developed direct watershed of 1,231. So the Lake Susan wetland or lake is actually it's impacted by that large watershed. You have more water that can bring in more pollutants, and that affects it there too. So that's another reason it's a little bit different than Lucy and Ann together. Okay, so those are the systems that we're looking at going through this process. So what do we think about when we think about watersheds in the built environment? What makes a healthy watershed in a suburban landscape? So we started this process just trying to think about what is it we want to pay attention to? What do we think defines a healthy watershed, and why does that make a difference? Well, first of all, why do we care about a healthy watershed? Well, economic savings. It reduces the cost for clean water, natural hydrology, and wildlife habitat. By having that green infrastructure, right, that natural infrastructure, that helps us in terms of water management and water quality management. And it does it much more cost effectively than if we have to engineer that. Sorry, Scott. So that kind of process. So that's important. Disaster resilience and climate protection. A healthy watershed will be resistant to disturbance, meaning that if you get a big storm that comes through, it can handle the flood. As a floodplain, it's not gouging out the channels with all that velocity, a lot of those other types of pieces. It also helps with climate change in that it absorbs greenhouse gases and maintains a balance of the greenhouse gases. So we're interested in that. Biodiversity and ecosystem function. This is really important for habitat. Having diverse ecosystems provides better habitat. If songbirds are coming through, they want to see lots of different types of trees because that provides a broad range of food, and it might provide a broad range of food over different seasons. So thinking about it that way. And then thinking about the human health and recreation. We love our outdoors, especially in Minnesota. We want to be able to recreate on it. We want to be able to use our lakes. We want to be able to use our streams. We want to be able to hike through the woods. That's a really important part of what we do as Minnesotans. So this is why we care about healthy watersheds and why we're thinking about this when it comes to connecting it to our lake systems.
Are we drinking the water from these lakes?
Not here, but it goes down to the Minnesota River, and eventually the Minnesota River makes it to the Mississippi, and now you're the water supply for cities all up and down
Including
the Mississippi. What's that?
Including Chanhassen.
Chanhassen's groundwater, right? Yeah, it's all driven by groundwater. You're not drinking the water out of these lakes, but it does affect drinking water when you look at how it affects downstream. So we're not looking at drinking water specifically in this study. Yeah. So then I started asking the question, what is a healthy watershed? Well, we can start to pick this apart. Well, it has natural land cover, right? When we think about uplands, we want to have natural land cover that infiltrates the water, that doesn't just run it strictly to a pipe that delivers it to our lakes. We think about good water quality and flow, right? The timing of how that water goes through there. You don't want to have really strong flows that gouge out your streams and stream bank erosion and all those other factors that are in there. You have connected habitats, meaning fish can use connected habitat, right? If it's a really steep pipe, they can't swim up it because of velocity, then they're disconnected from habitat, which might limit that fish community. Biodiversity, that's a healthy population of fish, wildlife, plants. And then functional ecosystems, meaning that when you put them all together, they're working together to maintain a resilient system. That's your kind of intact floodplains and riparian zones. They're working to mitigate the big storms that kind of come through there. Functional habitat that supports the species you're interested in, the species that should be growing in those areas, things like that. And then resilient to disturbance. So when you get these big storms that come through, or you get maybe an invasive species, they can kind of handle that disturbance in those systems. Okay, so this is kind of, again, just working you through our thought process. So when we think about a suburban watershed, I think about it two ways. I like to pick it apart. What are the different components of a watershed that I'm interested in? And then what are the functions that those are supplying? So what we decided for this study is we were going to focus on the lakes, the ponds, the wetlands, and the uplands. A study was already done. I'll talk about it for the uplands so we can just bring that into the work that we're doing and then tie that together. Streams and floodplains are important, but that's not part of this study because we're focused on the lakes themselves. So that I should have updated the Mitchell Lake one, but when we talk about the stream coming through here, that's a part of other studies that the district's been working on. There's already been a lot of work done to stabilize the stream banks through this drainage area and to improve those stream systems. So that's a different part of the study. So we're not going to look at that exactly. We're going to look at the other parts. Okay, so we're going to look at the lakes, ponds, wetlands, and uplands. And then what functions are we going to look at? They do a lot of different functions in a watershed, but we had to pick a few to get a bite-sized chunk here, right? If we tried to do everything, it would have gotten too complicated. So the functions that we're looking at is nutrient cycling. I'm going to talk about why phosphorus is important, but we're going to look at nitrogen. So one of the things that we're interested in is in these suburban watersheds is, does it make sense to manage nitrogen? Should we be doing something to manage that nutrient, that microalgae? And we'll talk about that a little bit more. Flood storage, that's why the district was originally formed. All the watershed districts were originally formed for flood mitigation. So we'll continue to look at that function. We don't want to come in with a water quality project and say, oh, do something with this wetland and that causes flooding downstream, right? We want to know which wetlands and what areas are maintaining flood conditions or the non-flooding that's going on in that system. We're going to look at biodiversity where we have that information, and then when we're done with that, we're going to balance in recreation. Okay, so the district, their primary objective is not to look at recreation or recreation management, but we all recognize that we want to recreate in these watersheds and we want to recreate on these lakes. So the question is can we have a healthy ecological condition that provides all the functions that it needs to be a resilient system, and we still enjoy it in some ways that we want to enjoy it. So we layer that in on top. And I can tell you now, I can't promise you that we can use the lake in every way that we want to and still maintain some of those ecological conditions. Okay, so that's why we call it a balance piece that's in there. So that's what we're trying to do with this study, and we're going to start diving into some of the specifics. So in 2024, the Ecosystem Health Action Plan, the district developed this study, and it was really focused on the uplands. And the main takeaway from this is really trying to convert these gray spaces, that's all your impervious surface, roads, sidewalks, driveways, rooftops, all those impervious surfaces that direct the water directly into the system, trying to reduce those and increase the green spaces. The green spaces will infiltrate that water, it'll go into groundwater, it'll slow down the flow that goes in there, and that'll benefit all the systems that are in there. So we're taking, and that eventually benefits all the water resources, the lake, streams, and wetlands. It benefits everything to have healthy uplands. So we're going to take the work that was done in EHAP and we're going to adopt that into our watersheds and identify areas where we think that uplands can be improved to support those water resources, knowing that the focus is moving from gray spaces to green spaces.
Joe, could I cut in really quick?
Yeah.
If you'll notice on the gray spaces, you'll see some turf grass, some lawn in there. In some cases, especially in the newer developments, turf grass can act very much like a hard surface where it doesn't allow rainwater or storm water to infiltrate into the soil. So that's why you see standard turf grass on that gray spaces side of the scale.
Okay, so that's uplands. The other thing we're going to look at are stormwater ponds and wetlands. I showed you that map where everything was plumbed together, right? The water was flowing through a series of ponds and wetlands. We want to know how those systems are functioning together. And this is really common in any Minnesota watershed where you have a lake system that looks like this. You have ponds, these are two big ponds. You have smaller ponds, these are covered in duckweed. Sometimes they're covered in blue-green algae. There's all these different factors. So we're diving into each of those ponds in a more deep scale to try to understand how can we manage these ponds and wetlands to provide or improve those functions in the watershed that we're looking for, and focusing on the 4 functions that are in there. Flood control, nutrient cycling, phosphorus, nitrogen. We look at sediment because these 2 are associated with that, and then biodiversity.
How small of a pond are you going to be diving into?
We build them in, got to remember when we built in the model in P8 what the smallest one is. Almost all the ponds that are in the system will be built into the model. That's
Even the small ones that are in the developments?
Yep. If we have design plans for those, we built those into our modeling tools and started compiling information about those. So there's very few that we don't have. Sometimes there's an isolated wetland that doesn't, it has a closed basin, it doesn't have to be discharged anywhere. Sometimes those aren't as included in our system because we're interested in the ones that are plumbed and connected to our lake system. And then we're going to look at some stressors. So those are the functions, those are the pieces of the watershed and the functions we're looking at. But some things stress it out. We always talk about impervious surface, but along with impervious surface comes roads, and in a winter climate, along with roads comes chloride. And chloride at high enough concentrations can be toxic to fish and macroinvertebrates and zooplankton. So we want to look at chloride and how that might be affecting the ecosystem as a stressor. So it doesn't provide any function. Well, it provides a function of allowing you to drive around in the winter, but it doesn't provide an ecosystem function when we talk about that. Okay, but we are going to look at chloride. We're going to look at nutrients. Nutrients, you need a certain amount to support your the base of the food chain. But when you get too much of it, it's like when you have too much sugar, it has bad impacts or deleterious impacts on the system. We'll look at that unnatural hydrology and flooding in areas. A lot of that work's already been done. And then pipe and ditch conveyance. So one of the things that we've looked at is areas where pipes might represent fish passage barriers. And then we're starting to look at the watershed and say, are there places that should be connected for fisheries that aren't connected? And what could we do about it? So those types of questions as we go through it. So it's really a holistic watershed and lake management plan where we're looking at the connectivity between the lake and the watershed. We're going to build as much as we can on the extensive work that the district has already done They do a lot of work around water quality, aquatic vegetation management, fisheries, and wetlands. We're trying to bring it all together into a plan so that we can identify areas where we can move forward and improve function in those systems. We're going to focus on these key watershed features, which is the uplands, ponds, wetlands, and lakes. We're going to focus on key ecosystem functions, which is the nutrient cycles. We want healthy nutrient cycles. We want to have good flood storage, so we're not having flooding issues, wet basements. And we want to have biodiverse and resilient systems. How do we build that into that? And then trying to balance some of those human values. That's that recreation, clean water, and habitat issues that's in there. So that's the overview of what we're trying to do, and we're trying to pull that all together, okay? We're trying to do it quantitatively, so we're actually measuring and taking information around each one of these. Should say we can hit a benchmark, say this is where we think the ecosystem function is operating. If our measurement is down here, how do we drive it to improving that system? So we want to be quantitative as much as we can. So let's talk about lakes in the built environment. So we talked a lot about the watershed, but now we're talking about lakes. These are two lakes. This is what, when you think of a Minnesota lake, you think of one of these two things, right? You think of on the left lake, the boundary waters, you have pristine watersheds, beautiful, clear water on all these areas, although they are having harmful algal blooms in the boundary waters, believe it or not. But that kind of system, or you think about your recreational deep lake, like on the right-hand side here, where you have your docks going out, and you have all your boats and toys, and you go out and you play on the lake. That's your traditional lake in there, okay? So when we think about Minnesota lakes, this is what most people think of. That's what they're drawn to, and that's what everybody wants their lake to be. But then we get to our lakes, and it looks something like this, right? Where we have lots of vegetation in the areas, in our shoreline areas, that might be growing to the surface or floatingly. We have some here that are, sorry, I should do it this way. You guys are all looking this direction. I'm looking over there. We have some here, like where the vegetation is growing almost to the surface, and that can become a recreational inhibitor, right? You get fish kills. A lot of these shallow lakes, like Susan or Red Rock, they go through these boom bust fisheries. It's a natural cycle, but you do get fish kills. And so sometimes you come out of the winter, and this is what you see, is a lot of dead fish floating on there. And then harmful algal blooms. These are toxic well, we don't know if they're toxic, but potentially toxic cyanobacteria blooms. This is on Centerville Lake. This is down in Iowa. But when you see this, stay away from it. That's when it has a potential toxic effect. So that's when you get too many nutrients in the water. We get these really robust blooms, and then they can be problematic. Or you can get the ones that are just annoying, like this is a lake in Egan where you have filamentous algae throughout the lake that's growing to the surface. This is water meal growing on one of the lakes in Egan too, which isn't as aesthetically pleasing. It's also indicative of high nutrient concentrations.
Is that different than duckweed?
Water meal and duckweed are very similar. They're both tiny floating leaf plants. So yeah, this one just happens to be water meal. It's just a smaller plant than the duckweed. They do. But it's not their primary food source, and it's not really their preferred food source, as I understand it. There's lots of other submerged aquatic species that they would prefer. And then they would prefer to have those submerged aquatic vegetation species that grow a lot of macroinvertebrates that are, living on those plants, and then that's what they really want to eat in there. So when you look at what the Minnesota DNR does in their shallow lake program, is they're looking at reinvigorating that submerged vegetation to provide that broad range of food sources for ducks. Told you we're going through a whole semester of ecology here. We're going to keep going. So then when I think about too, we broke the watershed into its parts. Let's break the lake into its parts. In the lake areas, we have these shoreland and upland areas. This is the transition from the upland, dry, well-drained areas into the lake itself, right? And that becomes the shoreland where you have bounce, you get water levels go up and down. That affects the vegetation and the soil processing that's going there. That's your shoreland area. Then you get that shallow water area. You'll hear me refer to that to as the littoral zone. Again, that's that area you expect plant growth. And then you get in deeper lakes like Lake Ann, you get these open water areas where it's too deep for light to make it all the way to the bottom. That's called an open water or pelagic zone. Okay, so we wouldn't expect plant growth, but then we get other processes that I'll talk about that affect the sediment chemistry, and that changes how that lake functions.
Is benthic zone the soil area? Just one more word, you haven't identified.
Yep, that's just the soil. The benthic zone would be that saturated soil that's interacting with the lake. That's where you would expect macroinvertebrates to grow and you'd sediment chemistry to change with those processes.
So that's what we're working with when we do the alum tree.
Correct. That's exactly it. Yep. Oh, I hit the wrong button. Okay, so let's talk about what happens in those zones, right? So this is a typical deep lake. What happens in the spring is it gets warmer out, the sun starts hitting the lake. It warms that surface layer. We call this the epilimnion. That's just that surface water. Water changes density with temperature. So warmer water is lighter, colder water is denser and heavier. And so it traps this layer of warm water on top, and then you get this cold, denser water that gets trapped on the bottom. So now there's not enough energy in the wind that would blow across the lake to mix it from top to bottom. Okay, this phenomenon is called stratification. And it's important because what happens is this cold bottom water gets trapped down here, oxygen can't make its way all the way down in there, right? And then this goes anoxic. This is a natural part, lakes do this naturally. This is not an unnatural piece of that. And then when you get anoxic water, you start to change the chemistry that's in the sediments or benthic zone, and that's where you start to get release of phosphorus and other things coming out of the sediments, and then that affects the nutrient cycling of the lake. That's easy to manage. Some of these other ones are harder to manage. Okay, so that's in the deep water. So Ann Lake's going to operate more like this, where it's going to be a stratified system. You're going to have warm water on top, cold water in the bottom, and it's not going to mix in throughout most of the summer that's in there. But a shallow lake, like Lake Susan or like Lake Lucy, doesn't ever get that deep in the middle. So this is now, we have all of the vegetation growing close to the surface throughout the lake because the bottom is so much closer to the surface of the lake. Now all these plants, macroinvertebrates, they all affect the water quality and how the lake functions, right? And the one before that, there's no plants down there, so it's all pure chemistry kind of process that's going on in here. Now we're adding biology into it and making it much more complicated. And then we have zones, and those shallower zones, you tend to get plants that can grow to the surface, or these floating leaf plants. Some lakes that we manage, that's what it is. It's that depth all the way across. And so you get plants that break or come to the surface all the way throughout that lake system. And then people can't recreate on it. So they have a lake that they didn't expect it. They wanted that deep lake with those big open water recreation, but they got a lake that's expected to grow plants, and sometimes it's shallow enough to grow it all the way to the surface. So now we have to start balancing what's our healthy system and what kind of recreational things do we want to do on it. Okay, so we think about shallow lakes and deep lakes differently. Lucy and Ann is a shallow lake draining into a deep lake, and we're going to manage those differently. They operate differently, but they're still connected to each other because what goes on in Lucy is going to have a direct impact on Ann. So deep lakes have that large open water area. These are more traditionally support recreational use because you can boat over that. There's no plants. You're not affecting the bottom sediments. You know, you can recreate on that without as much impact on the lake system. And these really tend to respond directly to management actions. What I do in the watershed has a direct impact on what goes on in the lake. Okay? In a shallow lake system, I can work in the watershed for years or decades, and it never changes the lake itself, because I'm going to tell you why that is in a minute. Okay, so then in these shallow lakes, we have limited open water areas for recreational use. We get a lot more plant growth to the surface. Those aquatic plants grow throughout the lake, and an often indirect response to management actions, meaning you have to set the stage, and then you have to force the lake to change. Okay? Makes it a little bit harder, but a little more fun. So what is that? That's called what we call competing equilibria in shallow lakes, meaning that a shallow lake wants to be in one of two conditions. It wants to be in a clear plant-dominated system, or it wants to be in a turbid algae-dominated system. If we're in this turbid algae-dominated system, we can't grow plants because the algae are shading them out, they're stealing all the sunlight and nutrients, and they're operating on their own. But this is when you get those cyanobacteria blooms that can be harmful. This is when you get those toxic, potentially toxic blooms. And so this is a very precarious position to be in. And the plant-dominated state, these plants help stabilize the bottom of the lake. They provide fish habitat. They also provide habitat for these grazers that eat algae. There's some that are very efficient. You want more of those. But what happens is the lake can be at either one of these states. It doesn't want to sit in between. And so if you look at it at low nutrients, this is like from poor nutrients to high nutrients. This is high turbidity to low turbidity. At low nutrients and low turbidity, it's very stable in this plant-dominated state, meaning that it's resistant to disturbance. So if you get a big storm that comes through, or you get invasive species, it can handle some of those systems because it's in a healthy condition. As you increase the nutrients, it tends to want to be in either one of those states, and it can flip-flop between those states that are in there. And if you get too many nutrients, it tends to stay in this turbid water state. Okay, so what do people ask me? Like, well, I want my shallow lake to be clear water with no plants so I can boat on it. Now you're asking me to take this ball and to balance it right on top of this little hill. It just doesn't want to stay there. It's going to go one way or the other. And we need to have those plants in the system to maintain that clear water. So this is what we're facing when we're thinking about managing shallow lake systems. So we have kind of a dichotomy of choices. What do we want our shallow lake to be? Well, in some cases, if it's an algae-dominated state, you can have contact recreation, although I would argue limited because you have the potential for harmful algal blooms. It has a poor recreational fishery. This doesn't support the fish community. So if you like to fish, you're not going to be able to, if you like bullheads, it'll do pretty well in that kind of situation. And it has user-specific aesthetics. But there are people that tell me I'd rather have this lake because I can boat on it, right? So the other choice is to have the plant-dominated state. Now we support the fisheries. We can have contact recreation safely. It has wildlife habitat, but it may limit some recreational boating or other user-specific. These are the two choices that we have, okay? And I can tell you state regulations say that we want this state because it's the most ecologically healthy, it's the most natural condition. So this is really what all the state water quality guidelines that I'll show you are focused on. So this is the challenge we're facing when we're managing these lake systems. So if you take home one thing at the end of this, it's that plants are the linchpin, the key part of managing shallow lakes. If we have a healthy aquatic plant community, that's what's going to maintain water quality and habitat and all those other features. So that's what we have on the handout here. It's just a lot of the different functions that plants support when they're in shallow lakes. It's habitat and food cover for fish. It absorbs wind and wave energy to prevent resuspension of those sediments and that sediment chemistry changes. It provides habitat for attached algae, which feed the macroinvertebrates, which feed the fish. It also supports healthy biogeochemical cycles, meaning that it helps gas off nitrogen out of the system. So if you have an excess of nitrogen, it loses it from the system through that process. So the plants support all of this. When we lose the plants, we lose all these functions, and that's why we end up in that turbid water state where the lake is very unmanageable and very unpredictable at that point. Okay? So plants are going to be a big part of what we do. So just give you an idea too, we're also developing some fisheries management recommendations as a part of this. So a healthy fishery stabilizes that lake ecosystem. It helps support the nutrient cycling and water clarity and supports vegetation. Plus, they're fun to go fish and pull out of the lake. The DNR is the lead management agency for fisheries in these lakes, and they really focus on the recreational fishery. So part of these plans is really going to be working with the DNR to say, how can we support the work that you're doing and balance the ecological condition that we want in those lakes. So we're really focused on that water quality ecology and reducing stressors as a part of this study that are in there. But we want to work together with the DNR to do that. We also are looking at healthy shorelines. The district went out and surveyed all the shorelines and all the lakes in the district using this DNR tool called Score Your Shore. And so you can see properties that have grass all the way down, don't offer much wildlife value. They don't have a lot of submerged aquatic vegetation, whereas you get a more complex shoreline that supports more habitat and fish in there. So there's a tool that we can use to identify which ones are degraded and what are the factors that are missing in there. And we can use that to make some decisions about how we might restore the shorelines in these areas. And then we built modeling tools to look at those nutrient cycles and the flooding cycles. You can just see here, these are the sub-watersheds that all drain down through together. And then we know how much phosphorus is loading out of there. And we'll talk about that a little bit later, why that's important. But we also know how much nitrogen and how much sediment is coming out of those. And then we can start to figure out where can we manage that in the watershed to support a healthy nutrient cycle in the lakes themselves. And for those of you that are from Susan Lake, you probably see how much greener it is than the other two lakes. It stands out like how much algae is growing in Lake Susan. Okay, so we're building these tools and we have all these at our disposal to start making management decisions. So now I'd like to go through this table in detail, like why am I kidding? I just wanted to show you the kind of information that we have pulled together. So we have all the information about nutrient cycles. We use tools and models to look at that. We also pulled in where if it's a jurisdictional wetland in the watershed, meaning that it's a wetland that's managed for lots of different conditions, flood control and water quality and habitat. We have all that information because the district's been surveying all those wetlands to get an idea of how healthy they are. So, and one of those might be habitat for fish. Is this wetland important for fish habitat? Does this wetland have good diversity? These two have low diversity, that has moderate. And flood control, how important are they in flood control? So again, this is where we're pulling all those functions together and trying to stack them on each of these different components of the watershed and asking the question, how important is this particular wetland or pond in supporting the different functions that we want? And then we can stack those together and prioritize which ones we want to go do some restoration work on. Okay, any questions on that? That's the big picture of what we're doing, trying to give you an idea of the tools, our approach, and how we're bringing this all together. And we'll come back at some future meetings to talk about what the results are. We're getting really close to that. Yeah.
You do a census of animals while you're like muskrats and deer and all that stuff around all these.
Yeah.
Part of your.
Yeah, it's not part of what we're looking at as part of this study. So that wildlife habitat, we're looking at the habitat itself. So we'll say, oh, you need to have no invasive species and this level of diversity. We'll look at whether it's connected or not through the stream corridors, if it's fragmented, but we're not looking at the actual wildlife. That would be a DNR effort that looks at that level. Again, we had to kind of pick and choose what we could go after in this study.
Does your group also review building plans like the memory care center by Lake Ann? Did you review whether or not that would have a watershed?
Yep, that will be done by the district engineer. And they look the district has rules of what needs to be met for good stormwater management, for healthy stormwater management. And so the district and the engineer will review that development and make sure it meets those rules that's protecting water quality that's in there. And then we use those plan development, that's what we built into that tool to get the idea of watershed loading and those biogeochemical cycles that are going on in the watershed. We're gonna give you honorary degrees by the time we're out of here. Other questions on the big picture? Okay.
How much recharge is there into the lakes?
I'm sorry, what's that?
How much recharge is there going into Ann and?
Groundwater. We have the groundwater built into our water quality models that's in there. I don't know the answer to exactly what the groundwater dynamics are.
I'm thinking precipitation into.
Direct precipitation?
Isn't that going into the soils and then is there?
Yeah, that's what I'm saying. We have that groundwater component. So we know, well, the way that I look at most of the lakes that we deal with is they're called flow-through lakes, meaning that if you get into that superficial groundwater, the water table, it's going to enter the lake in one spot and it's going to leave the lake in another one. Okay, it's rare that you're gaining a lot of water from groundwater but not losing it through that. So we build into our model and our tool, we know how much water is coming in from the groundwater table and how much is leaving from the groundwater table. And then we use that to manage our water balance, and then we can assign nutrient loads associated with that. But the general rule is what's coming in is usually equal to what's going out. So it becomes a wash in our water quality response model.
Thinking about the water cycle. You're not talking to that at all.
Yeah, we're looking at the lake and the watershed. Groundwater is not a part of our study, just as a part of this. We are looking at that as part of other studies with the district, but as part of this, we're not really looking at groundwater.
It's important for climate change, so that's why.
It is, yeah, no question, yeah, right. But we had to take bite-sized chunks. We had to try to grab some things that we could to really analyze, and then we can step towards those things. We're really relying on the EHAC analysis, that Upland Ecological Health Assessment Project. We're really relying on that to identify areas where those improvements can be made.
Fish IBI.
Fish IBIs are part of the study that we're doing. So we're using those fish IBIs to identify stressors. We're getting into the weeds of the details now, right, of the study that will come the next time. We're just trying to stay high level. But we are using those fish IBIs to identify what are the stressors to the fish community, and so that we can manage those specifically. So part of the fish program right now, as we know, What kind of fishery should it be? Most of these are going to be pike, bass, bluegill fisheries. That's really what they're structured for. And then what's stressing those fish out? And then how can we build that into a program to improve that habitat in those conditions?
Someone doing this with Lake Minnetonka too? I mean, just,
Well, that would be Minnehaha Creek Watershed District, and they've got their approach that they're doing something similar. I don't know exactly what they're doing, but they have their sub-watershed studies where they're looking at.
Joe started him down that track a long time.
I did. I did.
And Joe, you mentioned earlier about shallow lakes, deep lakes, complex lake. Lake Minnetonka is a highly complex
It
lake.
is. That's a good point, yeah. It's much harder to manage Lake Minnetonka. You have to break it down into all its bays and arms and try to figure out all those interactions. It's much more difficult. These smaller lakes are easier from that standpoint. Other questions or good questions? Okay, let's just go through what we know a little bit about these different systems, and I won't belabor these too much. But this is just an idea. You've heard me mention phosphorus earlier, why we focus on phosphorus. Phosphorus is the primary nutrient that grows algae. So it's also what we would call the limiting nutrient. So if you add more phosphorus, you get more algae, and the water clarity looks like this. You take the phosphorus away, and it starts to bring the system back into here. So if we want to manage how much algae we have in the system and the clarity of the water, we start with managing phosphorus. We're going to talk a lot about in the studies for phosphorus. But the district's been looking at phosphorus in the watershed for decades and identifying opportunities, and we keep drilling down and finding more and more opportunities to reduce phosphorus. Okay, so this is just a scale here of low phosphorus. This is 3 to 10 micrograms per liter is very clear water. And when you get into hypereutrophic, this is when you have risk for harmful algal blooms. That's when you get into this really poor water clarity. We measure that water clarity a lot of times with this disc. You'll see it's like black and white disc or an all white disc. That's called a Secchi disc. And as you lower it into the water column, you can measure how deep it goes before it disappears. Okay, and so another way you can do that is a healthy lake, you should be able to wade in about chest deep and see your toes. That's usually about what the standard is. Okay, so these are the tools, these are some of the measures that we use to determine how healthy the nutrient cycles in the lake are. So then I use box plots, and sorry, I know these are a little bit technical, but this really, each of these boxes is for a year, and it just shows you the spread of the data. So this would be the maximum data, the minimum data. That's in there. Sometimes there's an outlier that's really high, and that's where these dots come in. So I can look at the spread of the data every year. And this gets really important when we start manipulating cycles. So what you see when you do an alum treatment, which is a technique we use to bind up phosphorus, is we can see that squish really together so we don't get much distribution, and then you see it start to spread back out again. This helps me understand from year to year what might be happening. But this is just total phosphorus, and the line here is the standard. So you can see for Lake Lucy, you have periods where it's actually been below the standard for phosphorus, and then periods where it's gone above. But overall, the trend over the last 20 plus 30 years has been very high nutrient concentrations, and that results in growing a lot of algae, right? But look what happens when you have the low phosphorus concentrations in these other years. Look what happened to the algae. That's that relationship between algae growth and phosphorus. And this is why we're going to focus on that. But these are some pretty severe algae blooms when you have your median concentration up over 75 micrograms per liter. Those would create some pretty nasty algae blooms that are in there. That's what we want to manage. We want to reduce that. We're also looking at nitrogen. This is nitrogen in your system. Nitrogen can tell you a lot of different things that's in there, but from a concentration standpoint, you can see it's lower in that 2021 to 2023. That's also when you have low phosphorus and low algae that's in there. So both of these are important for the growth of algae. This one just is more limiting than nitrogen. It's more limiting than nitrogen because some algae can make their own nitrogen. They actually can pull it out of the atmosphere. So I can starve a lake of all its nitrogen, but then there's certain species that will grow and just pull it out of the atmosphere, and now we're back to where we were. That's why we look at phosphorus more than nitrogen. But what you can tell is in 2025, this nitrogen was really high. We had really big algae blooms. I would bet money that those were cyanobacteria blooms, because cyanobacteria are those species that can fix the nitrogen. There's lots of little stories that come out of these, looking at these water quality graphs that we come on. Okay, but what does this tell me is there's a lot of nutrients in Lake Lucy, and it's resulting in severe algae blooms. There are periods where it's been lower phosphorus. We want to try to understand why we might have lower phosphorus. There's lots of reasons, and that'll help us develop a management plan. And then we can ask this question about nitrogen is, will managing nitrogen in the watershed make a difference in the lake and how it's structured? Because that's important to the district, right? If you want to, should we spend money on building or managing nitrogen in the watershed? We want to answer that question, and I don't have a true answer for that. Lake Ann, again, here's the water quality standard. Look at where the phosphorus is. It's in a much better condition, right? The phosphorus is low. And for the most part, we see much lower chlorophyll A, which is a measure of how much algae we're growing in that system. And we have lower nitrogen in that system. They all kind of are connected to each other. But what I did see was in more recent years, there's been some pretty severe blooms on Lake Ann. Not really sure what that's about. So we're trying to figure out what might be going on in terms of that system. But you do see an increasing trend in the total phosphorus.
Since Prince died, and now we've got more development.
That might be part of it, more development in the watershed. I also looked at the bottom phosphorus, which we didn't have time to go through everything here. I didn't want to keep you here all night. But the bottom phosphorus is actually increasing up in Lake Ann. So I think the fact that you have more algae growing than what you would expect for the amount of phosphorus you have in there has to do with that trapped bottom water has a lot of phosphorus in it. And some cyanobacteria they have buoyancy regulators, meaning they can go up during the day and get all the sunlight, and then they can let themselves sink and get all the nutrients, and then they go back up and get the sunlight, and so they can outcompete all the other ones that are out there. So these are the things that we're looking at in that system, but I think, this shows some signs of weakening in the water quality, and so we need to ask the question, is it that bottom water? Is it sediment loading that's going on? Is it coming from Lake Lucy? Because Lucy had higher water quality. And so if we manage Lake Lucy to better water quality, will that improve Lake Ann enough? Or is it a function of development in the watershed, as development has increased, as properties change hands? Those are all the questions we're trying to answer so we can develop a strategy for improving water quality. And I have answers to some of those questions. I'm just not going to tell you what they are tonight. I'm saving that for the next one. I need to have something to draw you back. I want you to come back, right? Like, this guy's really boring and talks a lot. I gotta get you back in. Again, when we look at Lake Susan, look at the nutrients. I mean, the phosphorus concentrations back in the 1970s were really, really high. 150 to 200 micrograms per liter when the standard is 60 micrograms per liter. So you're like 3 times the standard that's in there. There's been some improvement. It's leveled out in more recent decades into this amount, but there's still a lot of phosphorus in there. And look at the chlorophyll. I mean, you guys are growing algae very effectively in Lake Susan. Again, I think we have a lot of reasons why, and I think we can fix this. It's just a matter of getting to the bottom of what's driving the algal growth. And you can see back in the day, this is back in the early 2000s, when you have some of these really severe algae blooms, nitrogen was really high in some of those years. Now, is that because it was coming from the watershed and creating more algal growth, or were the species that was fixing it? That's what we have modeling tools to figure that out to help us understand. Will managing nitrogen make a difference in these lakes? And then this all relates to water clarity. Again, in these shallow lakes, especially like Lake Susan, we want plant growth, so we want water clarity. You can see in Lake Ann, look, the water clarity is actually pretty good from 2 to 4 meters, which is about, what's that, 2 to 4 is like 6 to 10 feet in depth. So that's about like 6 feet. That's why I say chest deep and see your toes. Depends on how tall you are, right? I guess you're my height. But that's about that number. But you can see in Lake Lucy, the water clarity really bounces around. Some years you get pretty good water clarity, and in other years you get really poor water clarity. That's that flip-flopping between the turbid and plant dominated state. There's still a pretty healthy plant community going on in Lake Lucy, and so it's doing this oscillation depending on what's going on from year to year in terms of climate. And then Lake Susan just had poor water clarity really pretty much throughout the year because of all that algae growth, and that limits a lot of the aquatic vegetation that grows in there. So probably the only species you see, I can't remember, but is going to be, we'll get to that, it's going to be your invasive species. Both Eurasian water milfoil and curly leaf are adapted to poor water quality, which is why they do so well in some of our more degraded lakes. And then we want to look at stressors like chloride, asking the question. Now, most of these chloride samples are taken from April after ice out to the end of the summer, not when the heaviest time when you have chloride use in the watershed. it's hard to get out on the ice when it's rotting, right? Right now's the time I want to get chloride samples, but I'm not going to send field staff out on rotten ice. It's not safe. So it's hard to measure. So I just want you to know, but you can see it's pretty steady. In Lake Lucy and Lake Ann, these are less developed watersheds. They don't have as high of impervious surface, and they're really pretty steady. So to me, I don't see a trend anywhere in here that's really saying we are degrading chloride or getting really high chloride concentrations. But look at Lake Susan. Again, I told you it's that bigger watershed. I think it's driven by the watershed. Since 2019, it's been a steady increase in chloride concentrations. Now, obviously, this is going to vary depending on how severe the winter is, how much salt applied, how that salt moves through the watershed. It's really kind of a complex pattern. But when we have these values that we've seen, and some of these are in the fall, before a lot of ice or before a lot of snowfall events, those are concerning in terms of how they're going to affect fish, macrovertebrates, and the plants that are in the system. So part of what we're doing is looking at chloride management in the watershed, trying to link it to the lake, and get better information about how we can reduce chloride. And the district does a lot of work around better practices for chloride or de-icing.
It says here that you cannot get chloride out of the water ever. And it says 1 teaspoon of salt pollutes 5 gallons of water forever.
It doesn't take much chloride to really have an impact on the lake systems. And you're right, you can't remove it. The only way to remove it is reverse osmosis. And that doesn't even really remove it. It forces it through a filter and keeps all the chloride back here in a concentrated solution while the clean water goes through that system. That's super expensive and energy intensive to do. We can never do that for stormwater. We can do that for drinking water.
But I recommend that for all of Chanhassen citizens over 65 should have a shovel corps person to come out and shovel.
The shovel for them. I got that. Yeah. And use the ice scraper. Yeah.
Early and often.
Right.
Our snow service never shows up.
Well, yep, we're open for ideas. I think that's great. And then we look at shoreline conditions. Again, this is our lovely box plots, but the district went out and scored all the shore. Each of these dots is each one of the plots that was done along the shoreline. And you can see that some lakes, like Lake Ann, which has a pretty, I think, doesn't the city own a big part of the watershed? Yeah, a lot of parkland around it. So it actually has pretty good conditions. It's another thing that's helping water quality be maintained and good fishery maintained in Ann Lake. When we look at Lucy, the condition of shoreline gets much broader in scale and more degraded. Only about 62% were at that kind of mid threshold up in that piece. And then Lake Susan had even more degraded. Not the worst, but not Lake Riley or Lotus, which are the most developed watersheds, but pretty farly degraded that's in there. So the question now becomes a part of our study is what can we do? We're not going to pull all the houses out and make people move off the lake, but are there things we can do on the shoreline that would improve those conditions that would benefit that and still be able to recreate on that lake and still be able to use that lake in certain ways? Okay, that's the balancing part that's in there.
Seems like that's what's happening with Lake of the Isles and area. They're letting plants, or they're doing some kind of away from the shore.
Yep.
There's more plants and more things, yeah, to drain it naturally.
Yep. Great. So one of the metrics that we use is we want to know how many species, what's the species diversity that we see in the plant communities. This is a great one. Lucy and Ann both have pretty good species diversity, meaning that at Ann Lake we found, the surveyors found 22 different aquatic plant species when they went out there. That's a very good number. 15 is pretty good too. That's what it was for Lucy. And then look at Susan down at the bottom around 11. And the reason Susan's at the bottom again is water clarity, right? We don't have the water clarity that we need, so we can't grow the plants that help support that. It's this feedback loop that if we can get into a stable system, then we can start to manage that system. So we have good plant survey data for a lot of these lakes where the surveyors go out. So we can look at where the native plants are and what their density are. The bigger the dot, the more native plants there are in this one. This is density of the overall vegetation. So I have this desire to test you guys, but do you know why it's only ringed around there? What's that ringed area called? The littoral zone, right? That's the reason they're limited in that area is because that's the less than 15 feet. As you get out here, it's too deep to support plants. So that's our classic deep lake system. And we do have some Eurasian water milfoil. I don't know if it was found in, it was found in some prior surveys, I think, that's in there.
Yeah.
But it's not a problematic, it hasn't reached a problematic level that's in there. But that's what we want to know is, do we have a nice diverse aquatic plant community that supports those services that we have on here? And can it resist invasion by some of these invasive species that come in there? If it can't resist it, sometimes even stable systems can't resist that. That's where we need some intervention. That's why we go out and do aquatic plant management or AIS management. Lake Lucy, looking at this one again, we see a lot more coverage through the lake because there's a lot more shallow areas that's in there. We have pretty good density, but not as much diversity that's going on. So you can see a lot of these plants are dense, but it's dominated by one species. We want more diversity throughout the lake system. That's part of what we're going to look for in the management system that creates a more resilient and stable system. But pretty good. They're again, curly pondweed, Eurasian milfoil are present in Lucy, and I think there's some management. We're putting that stuff together. We're still working on that part of it, but trying to figure that out. And then Lake Susan. And you can see Lake Susan, we would expect plants really to go across from shore to shore. It's only growing in those very shallow areas. But what's there are native species and a little more on the diverse side. Some is 5 or 6, but they're all in the really shallow areas and density. There is curly pondweed existing in some of those areas and a little bit of Eurasian water milfoil, though not thick things in there. So if we go in and we do a lot of work clearing up the water, what do we expect these plants to do? They're going to expand throughout the lake system. So that's got to be part of our management plan, is to figure out how do we support the healthy plant system, how do we keep the invasive species out so it's a resilient system, and then can we balance some recreation with that too? And what does that look like if we're doing recreation on it? We're almost there. Fisheries, we are looking at fisheries. There's lots of different species. These are your centrarchids, so your bluegills and pumpkin seed, and then your top predators, and then your bottom feeders that are in here. Most of what we look at are carp as an invasive species. That's been a big part of what the district's done over the last 10 years. Is it 10 years, carp management?
Close to 20.
Yeah.
Close to 20, right? 20 years. They've really been a leader in carp management, and that's been a big part of it. But most of these lakes that you're talking about are a northern pike bass bluegill fishery. So if you're going to go to DNR and be like, I want this lake to be a walleye fishery, then you're probably say no. Unless they want to grow fingerlings in there that they're going to transfer to another lake at some point anyway. Sometimes they do that. But really, that's really what we're looking at, is how do we manage this northern pike bass bluegill fishery, where we have this kind of dominant bluegill population, where a lot of times we have this high abundance and small size structures. They get kind of stunted, they're small. We want a balanced community that's in there. Common carp are through this system and managed. That will be a part of what we're looking at too. We're not going to talk about that too much. But most of these have a pretty strong predatory fishery. It's all there, all the pieces are there, but if we can manage the habitat and the water quality, then that will help balance the system out. This is you at this point. So let's before we even get into this, let's say, okay, so that's kind of where we're at. That's what we know about the lake systems. We have the maps over here you can look at that show the watersheds and the drainage patterns. We're working through all that data. We're making management recommendations. Are there any questions on that second half of the presentation? And then I'll give it to Liz for the next steps.
What's the predatory fishery?
A predatory fishery is when you have top predators, so those are your pike that eat other fish. And so it's called a top-down control. The amount of top predators controls how many bluegills there are, right? Because they eat a lot of the young and that kind of stuff. You take that top predator out, bluegills go crazy because there's nothing to limit that population. So that's why we call it predatory. And then these shallow lake systems tend to be bass. They want fisheries that tend to edge hunt. So the bass like to sit on the edge of a vegetation line. They like to wait for the fish to swim by and then go out and grab it. And that kind of stuff. So it's more of those, it supports more of those types of fisheries. Yeah.
So chloride is a toxic contaminant. Phosphorus leads to algae. I missed your nitrogen.
Nitrogen is a secondary nutrient that can lead to algae. Okay, so if we can reduce phosphorus and nitrogen at the same time, we can probably be more effective at reducing the overall algae. But we do it mostly by phosphorus because nitrogen is hard to manage. And then nitrogen also controls what type of algae grow. So high nitrogen environments tend to grow the more toxic algae species. So we're looking at that balance too. We're trying to figure out, is there a role for nitrogen management? Will that benefit the lakes, or should we continue to focus on phosphorus? That's our best approach.
Okay, thank you.
Mm-hmm. See, I told you you had an honorary degree by the time you left. Other questions? Okay, we're just trying to set the stage. We're going to come back in a few months probably, and we're going to go through a lot of these results and say, this is what our plan is, or this is what we think you should do, manage these different components to bring those all back together. So with that, I'll let Liz talk about next steps.
Yeah, next steps really is just starting what Joe said. So this is round 1 of meetings. So we did a meeting focused on Lake Mitchell and Red Rock Lake last week in Eden Prairie. And this is the other meeting of round 1, which is focused on the 3 lakes that we talked about tonight. Round 2 is where Joe's going to start to reveal some of those findings that he's teased us about already. So we'll be learning exactly what we learned. And again, that'll be a couple of months down the road. Round 3, this is where we get to what we learned, what can we do about what we learned? So identification of potential projects, programs, and such. And we plan to do those this summer. And then by the end of May, again, much on the sooner end, we hope to have some draft plans that we'd like to bring to focus groups. And the focus groups that we're considering are different lake associations. To again have those small focus groups to talk about again what we learned, what we think might address some of the issues that we found. And then the final plans, so these are the watershed and lake management plans, finalized versions of those by the end of the year. So that's what we have coming up next. And then you'll see up there also, if you're interested in learning more about EHAP or our Ecosystem Health Action Plan, you can find it on our website at rpbcwd.org/EHAP. You can download the document and take a read and look at those strategies that we identified through that process. And then last but not least, there's the project page for what we've been talking about tonight. There is a form on there where you can submit a comment. You can also learn more about the project. What did our board of managers order? What are all the actions that are supposed to happen with this process? And then in addition to using the comment form on that page, we also have some comment forms on the table. So if you'd like to leave a comment tonight, you are welcome to fill out that form or visit the website later. We also have, like Joe pointed out, maps of the watersheds. Both one map is of Ann and Lucy and the other one is of Susan. So if there are certain things that you'd like to write on the map, either problem areas, or you can use a post-it note or use the marker on the map itself, just let us know about some of those areas that you have concerns about. With that, if you have questions, you can always feel free to contact myself or Terry Jeffrey, who is our district administrator, or Dylan Monahan, who's here tonight as our watershed planner. With that, yeah, questions? Yes?
2 questions.
Yeah.
The first one is, so at the end of the year, probably some very specific projects will have been identified to improve.
Right.
Is there funding for any of that now, so that next year we don't have to wait another whole year then for funding to be approved, or is that?
That's down there. So again, this is all helping to inform our 10-year management plan.
Okay.
So
it'll
helping
be
identify those
for the 10-year
projects, and
plan.
so funding comes later. Right now, it's identifying those projects and prioritizing those projects. So we have an existing prioritization scale right now, but we'll be re-looking at that for our 10-year management plan update. And then that's when we start setting our annual budget based upon those projects that we want to accomplish each year.
My second thing was to ask for that slide up so I could take a few more notes.
Yeah, there you go. We'll also, I'll get this uploaded to the webpage also and share that with people after the meeting. So this slide deck will be available as well. And maybe the recording, if it worked, we'll figure that out
Where are
later.
you attached to? You're not part of the city of Chanhassen?
No.
You're part of the Metropolitan Council or?
No,
What
so
is that?
we are a watershed district, so we are a local unit of government. Our boundary is determined by watersheds, it's not determined by the city, so we overlap portions of several cities, including Eden Prairie, Chanhassen, a little bit of Bloomington, a part of Minnetonka, Shorewood, Deep Haven, a little bit of Chaska. Who am I missing? Okay, I get them all, okay. And also like parts of 2 different counties. So we straddle the Carver County, Hennepin County line. So we are a local unit of government. Our funding comes from taxes, property taxes within the district. So that's how we are funded. We are, I guess our state organization that we report to is the Board of Water and Soil Resources, or BOWSR for short. So we have provided them with an annual report. We are overseen by a board of managers. Those are citizens appointed to serve as our board, and those are appointed by Hennepin County Commissioners appoint 4 positions, and Carver County Commissioners appoint 1 of the positions on our board of managers. So that's how we're organized and how we're funded.
In 1955, there was a Watershed Act passed, which allows citizens to petition to form a watershed district. And then in statute are the things that we're responsible for taking care of. So, floodplain.
Interesting.
Scott can rattle those off better than I can.
Yeah, and we relied on a lot of partnerships too. Obviously, City of Chanhassen, we've got Joe Seidel here tonight, who's a water resources engineer. Is that your title at the city? And then also we partner with other cities within our district as well. So partnerships play a huge role in what we do.
The more we can identify goals. to solve
Yeah,
some of
share
these problems.
goals, align our
Watershed has
plans.
grants available, which are competitive, so you're up against a whole lot of other districts and water management organizations. But
And we do have 2 of our managers from our board of managers here tonight. Jill Crafton, she's been on our board of managers for,
it's 2009.
yeah, so for a good bit. We also have Bonnie Nelson here, who's currently on our board of managers. She's a Carver County rep. And then we have David Ziegler, who was on our board of managers. He's right here, right there next to you. Yeah, he was on our board of managers for, I think, 2 terms, 6 years as well.
Well, partial term because someone resigned
Okay.
midterm, and then 2 full terms after that.
And I should also recognize we have a citizen advisory committee that advises our board of managers, and we've got representatives here tonight as well. So we have Andrew Aller, who's the chair of our citizen advisory committee. We have Sharon McCotter, who's been a long time on our citizen advisory committee, and also Ed Goff, or Goff, it's Goff, right? Okay, who's new this year to our citizen advisory committee.
David was on Citizen Advisory.
Oh, yeah, and David, before he was a manager, he was
And
also.
Bonnie.
And Bonnie. So, but yeah, are there any other questions from anyone? If not, you can certainly reach out to us. All of our contact information is on our Watershed District webpage. So you can email us, call us, or submit a comment form on the project page. With that, thank you very much for coming tonight. And like I said, if you want to leave a comment card, just write it, leave it on the table, or if you want to write a comment on either of the watershed maps, please feel free to do that as well. Thank you for coming.
Thank you. Very good. Thank you.